For this example, we're going to use the load on a sample image to apply a Gaussian filter to the image. To adjust the standard deviation level of the filter, we'll use a slider. Once the image has been filtered, we're going to show the results in a viewer env, and we'll use a split layout to show both the slider and the viewer with the resulting image in the same window. Once the boxes are deployed in the workbench, we must make the connections. The image data from the load box is connected to the image input of the filter. The resulting image data from the filter is connected to the viewer env image input. The output value from the slider is connected to the filter's standard deviation input values, that is, X, Y, and Z values. And the output windows from the slider and the viewer env are connected to the window inputs of the layout split. Now we must specify certain parameters for some boxes by double-clicking on them. In the slider, the maximum value is 10 and the minimum is 0. We also set the reactive on track parameter to true. In the viewer env, the end-type view parameter is set to -1 to see just the set view. And in the split layout, we set the proportion to 90% to give more space in the window to the viewer env. Finally, we set the layout split to be the box that starts the execution of the pipeline and execute the pipeline. As you can see, the image doesn't change when the slider is moved. That means the interactions are not set yet. Close the window and set the following connections. The slider notifies the filter when the slider is moved, and the filter notifies the viewer when the resulting image is changed. These changes will make the pipeline work as expected. The filter image changes as the slider is moved. Take close attention to interactions when creating pipelines. They play a great role on the execution of the pipelines.